Hi everyone, my name is Thomas Kim. Today is February 28th, 2021. This is my 106th episode about vector calculus and classical electromagnetism. In this episode, I will explain how to read books. We will also learn how to use SYCL debugging stream, SYCL stream. Data parallel C++, mastering DPC++ for programming heterogeneous system. This book has 20 chapters and approximately 500 pages long. I binge read this book in 2 or 3 days. I'm saying that I have read 500 pages in 2 or 3 days. Am I a super genius or something? Absolutely not. Then how can I read 500 pages in 2 or 3 days? How? The answer is very simple. I skipped some chapters. When you learn something for the first time, don't try to understand everything from the beginning. Instead, leave minute details behind and move on. Don't get bogged down on minute details. Try to get the big picture. To understand from chapter 1 through chapter 4, we have to understand from chapter 5 up to chapter 19, or even including epilogue, the last section. Always keep this point in mind. Don't try to understand everything from the beginning. Leave minute details behind and move on. Don't get bogged down. Always try to get the big picture. After getting the big picture, you can come back and cover minute details. I assume you have watched my previous video, episode 105, Hello SYCL, Data Parallel Programming using SYCL, SYCL-Q. If you haven't watched my previous video and do not understand what is Q, you may not be able to follow my current session. My current session can be the most challenging episode in this series. Without further ado, start your Visual Studio Code, open your working folder, click this button, 106, Debugging, Stream. Click this button, debug.cpp. Ctrl B, include talk play fun, output HPP, include CL, SYCL, HPP, talk play fun, S stream, auto, ender, talk play fun, ender. Void test debug stream int main, copy this, paste it here. Now we define int host memory. This is integer array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From this integer array, auto byte count size of host memory, stream byte count, and there now auto element count, byte count divided by size of int. Because the type of host memory is int, so we have to divide byte count by element size. Stream element count, and there we now declare Q, SYCL Q. We declared an instance of SYCL Q with default device selector. If you haven't watched my previous video, you may not understand what is queue. I highly recommend you to watch my previous video. Then you understand what is queue. Queue represents a device. Now, int, this is pointer, shared memory. SYCL, memory, allocate, shared, we provide element type. Element type is int. Then we have to provide size. This one. Not this member function. This member function. This is template. T is int. This count is element count. Then Q. We have to provide Q. So this is our Q. We allocate memory that can be shared between our CPU or host and GPU or device. So shared memory, this shared memory can be shared between CPU and GPU. As I said in my previous video, Q represents a device. So Q represents GPU device or CPU device. Now STD, MEM, CPY, we copy memory from host memory to shared memory. The first is target. The second is source. Source is host memory. Now we have to provide the size. This is byte size. So we have to pass byte count. We are copying host memory or CPU memory to the memory of the device or GPU. Because we allocated memory, we have to pre-SYCL, pre-shared memory. We have to provide Q. We have to pre the memory allocated in the device Q. Now we create a task to assign to our device. Or task, we will capture all as reference. Then SYCL handler as L-value reference handler. Don't forget semicolon. We are creating a task. SYCL stream output, we provide buffer size 1024 1 kilobyte. 1024 times 10, then handler. This handler, we created an instance of SYCL stream. Now here we use this handler parallel for we provide SYCL range. We captured as reference. We provide element count here. Then we create lambda. Don't forget semicolon. Now here I will arrange like this. We have to capture by value. we have to capture by value. I will discuss more about this shortly. Here we take SYCL ID 1. This is one-dimensional index. Then I. Here output. This output comes from here. Shared memory. This shared memory is integer pointer. So I. Then carriage return. Please understand that this part is a lambda inside a lambda. Don't concern about this too much. Now, auto event queue. This queue is this queue. We submit tasks. We submit a task to our device queue. Now, when we submit a task to device queue, it returns event. Event wait. We have to wait until the task is completed by the device queue. Now, start your command prompt. dir cd 106 debugging stream dp qsdd C++17. We don't need this option because C++17 standard is default. debug.cpp or d.exe, hit enter. cls d. So we created an array in the host memory. Then we created shared memory. We copied the host memory to shared memory. We created a task for our device queue. Then we assigned the task to the device. As soon as we submit a task to queue, this task is this lambda is executed immediately. But this part is executed and this queue returns an event. We have to wait until the task is completed. We use event wait. In this task, this part is executed immediately. Executed by the host or CPU. This part is executed by the GPU. This part is executed by the device or GPU. This lambda is called kernel or device code. Sorry, I will make some changes. In the Intel TBB, there is a class called TBB task. So I will change it to work. Copy this, paste it here. We submit a work to our device queue. We have to wait until the work is completed by the device queue. I made a small mistake. Auto buffer size. I will cut, paste it here. Auto max statement length cut, paste it here. I will put buffer size, max statement length. Also, I will cut like this, then paste it here. Or kernel, I change it like this, semicolon. Then here we copy this kernel, paste it here. This kernel is executed by the device. This code is executed by the host or CPU. This kernel is executed by the device. We build once again CLSD. It works perfectly. Please understand that this kernel is executed by the device. Here, auto device q get device string. Our kernel is executed by device get info SYCL info device name, and there we build again CLSC D. So our kernel, this kernel is executed by Intel graphics device. Please understand that we used output. Output is an instance of SYCL stream. We are printing out this message using output, an instance of a SYCL stream in the kernel. Kernel is executed by Intel graphics. Here's the mystery. How this output, this SYCL stream is implemented. I will talk more about all these things. So don't worry if you don't understand these things, because we will use this pattern all the time in future.